Even the nucleus of an atom, which we think of as so dense, pops in and out of existence just as readily as the electrons do. So it is not only the electrons that exist as waves and then pop into a specific location in space and time when they are observed, but also the nucleus. And the most recent research has even found that whole atoms and molecules do the same thing. Physicist Nick Herbert says this means that the world behind our back, where we are not looking and cannot observe, is always a radically ambiguous and ceaselessly flowing quantum soup. But whenever we turn around and try to see the soup, our glance instantly freezes it and turns it back into reality. Herbert believes this makes us all a little like Midas, the legendary king who never knew the feel of silk or the caress of a human hand, because everything he touched turned to gold. Likewise, we can never really know the true nature of the quantum universe, because every time we try to observe it, it turns into matter. Richard Feynman, a physics professor at the California Institute of Technology, is reported to have said that if you really understand this double-slit experiment, you can understand all of quantum physics. You will hear me say fairly often that one of the best clues or hints about how our universe actually works can be found in our kids' video games. Right now, take a short look at a game called Minecraft.
Oh man, here we go, people. Minecraft, let's play. Oh, I can't believe I've never done this before. This game is the sweetest game, man. Oh, it is so awesome. Well, I'm so excited to get started, guys. I hope you're going to enjoy the series as much as I'm going to enjoy playing it. And today, we're just going to set up for the first night. We're going to try and make sure that we find a good little pad. Oh, God! I think I broke something. We're going to look for a nice place to start up, and ooh. Oh God! Oh God! Oh God! This is not perfect, guys. This is absolutely perfect for our house. I'm gonna build my house right into the side of this mountain, and when we come out of the house, we're gonna come out with this amazing view of what can only be described as a rainforest. You know what I'm saying? Oh my God! This is so awesome. This is perfect. Yeah. I think I'm. Oh, yes, this is perfect. Wait, is there a tree above me? Oh my God, the sun is going down. The sun be going down.
Notice that when the player passes an object or turns in a new direction, whatever he had been looking at before disappears. Where does it go? Take a quick look again, and then we'll talk a lot more about that later.
Oh man, here we go, people. Minecraft, let's play. Oh, I can't believe I've never done this before. This game is the sweetest game, man. Oh, it is so awesome. Well, I'm so excited to get started, guys. I hope you're going to enjoy the series as much as I'm going to enjoy playing it.
Basically, unless the player is looking at something in the video game, it doesn't exist. It disappears, only to pop back up later if the player looks at it again. This is how quantum physics is telling us that our reality works as well. It means that our reality is not as real as we have always thought it was. Instead, as you hear many quantum physicists say, it pops in and out of existence. So, if matter is not solid, and reality is not real, what is this physical universe that we experience and think of as so solid, that looks and feels so real to us? Two models have been developed to answer that question. One is the field, and the other is the holographic universe. We're going to take a close look at both of those models, starting with the field. When we speak of an electron existing as a wave, it isn't like an ocean wave or a radio wave. It is more like a wave of possible locations where the electron could end up as a particle when it is observed. It's a wave of possibilities. This wave of possibilities in which the quantum world exists has been called many names over the years, such as the quantum wave function, which you heard Fred Alan Wolf talk about, the implicate order, which was David Boehm's term, the Planck scale, named after Dr. Max Planck. These scientists apparently like to name things after themselves. The zero-point field, named of course for Dr. Zero Point. The superstring field, and the unified field. Mainly it is just called the field. It is a field of unlimited possibilities out of which everything is created. Lynn McTaggart, author of The Field, defines it as a field of all possibility. In other words, everything you can think of, and everything you can't think of, and everything no one has thought of yet, already exists in wave form in the field.
Progress in our understanding of the universe through physics over the past quarter century has been exploring deeper levels of natural law, from the macroscopic to the microscopic, from the molecular to the atomic to the nuclear to subnuclear levels of nature's functioning, so-called electroweak unified scale, grand unified scale, super unified scale. And what we've discovered at the core basis of the universe, the foundation of the universe, is this single universal field of intelligence, a field which unites gravity with electromagnetism, light, with radioactivity, with the nuclear force, so that all the forces of nature and all the so-called particles of nature, quarks, leptons, protons, neutrons, are now understood to be just different ripples on a single ocean of existence. That's called the unified field or superstring field, a single universal field of intelligence, an ocean of existence at the basis of everything, mind and matter. And all the so-called particles of the universe, the forces in our universe, everything in the universe are just ripples on that ocean of existence. That's the unified field. And that field is a non-material field. Planets, trees, people, animals, we're all just waves of vibration of this underlying unified superstring field. We're really living in a thought universe, a conceptual universe. Quantum mechanics is just the play and display of potentiality. So the point I'm making is the deeper you go in the structure of natural law, the less material, the less inert, the less dead the universe is, the more alive, the more conscious the universe becomes. Then when you get to the foundation of the universe, the unified field or superstring field, it's simply a field of pure intelligence. Intelligence because it's the fountainhead of all the laws of nature, all the fundamental forces, all the fundamental particles, all the laws governing life at every level of the universe have their unified source in the unified field. That makes the unified field the most concentrated field of intelligence in nature. Non-material, dynamic intelligence. Those are the properties of the unified field. So, as you said, the tighter physics have tried to grasp onto physical reality, to understand what it's really made of. What are the core building blocks of life at the basis of it all? Life, the universe, slips through your fingers. And you come up with something that's increasingly abstract to come to the realm of pure abstraction. And that's what the unified field is. It's pure abstract potential, which rises in waves of vibration to give rise to the particles, the people, everything we see in the vast universe.
So, the field is a place outside of space and time where everything, all possibilities, already exists, but only in wave form. This field does not contain particles. It is not matter. It is not part of the physical universe. Instead, it is what the entire universe is made from these waves of possibilities.
Physicists give this a name. They call it our quantum wave function because it seems wavy. However, this wave function isn't just a wave of matter like an ocean wave or a sound wave or any kind of wave of matter. It's a wave of possibility. It's a kind of thought wave. And because it is a wave of thought or possibility or not matter, it's invisible to us. But we can't explain what we do see as matter in these small corners of space and time unless we picture that these matter particles somehow come out from or emerge from these thought wave patterns which are invisible to us.
Quantum mechanics is really the play and display of information, the play and display of potentiality, waves of information, waves of potential electron. And it's important, the word potential. This isn't the world of electrons, it's the world of potential electrons. But when you have to ask the question, waves of what, really? What is the field that is waving? Is it the ocean? No, it's a universal ocean, an ocean of pure potentiality, an ocean of abstract potential existence. We call it the unified field, or superstring field. And that's what we're made of.
Fred Alan Wolf said something very important. We can't explain what we do see as matter unless we picture that these matter particles somehow come out from or emerge from these thought wave patterns. The problem is that no one can prove that the field exists. You can't see it, you can't photograph it, you can't measure it, you can't hold it in your hand. But when quantum physicists assume the field is there, they can make incredibly accurate mathematical predictions about the physical universe and how it behaves, which they cannot do without assuming the field is there. Think of it like electricity. You can't see electricity itself. You can only see what electricity produces, the light it makes, and the power, and the other effects we count on every day. And when we see those effects, we know that electricity must exist. The same thing is true for the field. Even though we can't prove it exists, nothing makes sense without it in light of the results of the most recent scientific experiments. Think about taking a radio to a tribe in the Amazon who had never seen one before. I can imagine that the natives would stare at that little box for a while, trying to figure out how the music came out of it. They might even tear it apart, looking for very little people inside playing very small instruments. But eventually they would deduce that there must be radio waves in the air that they couldn't see and couldn't prove existed, that this little box could receive and translate into sounds they could hear. That's what we're dealing with when it comes to the field. We can't see it, we can't prove it, but we know from looking at the effects that the field must exist. But how did this field come into being? Who made it? Where did it come from? Why is it there? Science has no answers for these questions. They only know that the field must exist. So I will not talk about how the field was created, or who might have created it, or how it already contains all possibilities, because I want to stick only to the science right now in this presentation. We will have to leave that discussion for another time. The next question we can ask, though, is how is reality created from the field? Most quantum physicists agree that it is a very similar process to the creation of a hologram. In other words, the universe we see is a holographic universe.
When we look at some of the modern scientific views of reality that have tried to get down...
Even the nucleus of an atom, which we think of as so dense, pops in and out of existence just as readily as the electrons do. So it is not only the electrons that exist as waves and then pop into a specific location in space and time when they are observed, but also the nucleus, because everything he touched turned to gold. Likewise, we can never really know the true nature of the quantum universe, because every time we try to observe it, it turns into matter. Richard Feynman, a physics professor at the California Institute of Technology, is reported to have said that if you really understand this double-slit experiment, you can understand all of quantum physics. You will hear me say fairly often that one of the best clues or hints about how our universe actually works can be found in our kids' video games. Right now, following quantum soup. But whenever we turn around and try to see the soup, our glance instantly freezes it and turns it back into reality. Herbert believes this makes us all a little like Midas, the legendary king who never knew the feel of silk or the caress of a human hand. And the most recent research has even found that whole atoms and molecules do the same thing. Physicist Nick Herbert says this means that the world behind our back, where we are not looking and cannot observe, is always a radically ambiguous and ceaselessly